Got too many windows open.
All right, welcome to the AI Unplugged Mastermind. Today we have a guest all the way from Adelaide, Australia, Dr. Jaime Sherrah, who has a PhD in machine learning. He has been involved in AI for 25 years. And I thought it would be good to get the perspective of someone who has been deep in these projects for a very long time. And he will be sharing some case studies and also open to your questions. I know Mackenzie is at their company, savealife.org. They are implementing a lot of different AI things, and she might have some questions on some custom AI uses inspired by what you're going to share. So I will let you go ahead. Are you ready?
Yep.
All
Thanks,
right.
Nicole.
Yeah, thanks, Jamie.
Thanks, Nicole. I'll share my screen. I've got a presentation. Okay. Yeah. Hi, everyone. I hope you can see my slides there. Thanks for inviting me to talk. I'm in EO Accelerator in Adelaide, which is in the southern part of Australia. So we're neighbours to the penguins in Antarctica, but it still gets pretty hot here. It's not as cold as Antarctica. And today I'm going to talk to you a bit about some of the stuff we do with AI and machine learning in my company, Inject AI. And what I want you to get from the talk, I guess, is a lot of you using tools like ChatGPT and Midjourney and those text-based tools or generative AI tools. But what I want to get you to get from today is a sense that there's more to AI and machine learning than generative AI, and that the diversity of applications of AI and machine learning usually revolve around diversity of data. So, some weird data that ChatGPT doesn't work so well with, for example. And so there's a lot of cases where using an off-the-shelf tool is not going to work for you, and that's where you might need a custom machine learning solution or AI solution that's customized for your use case and your data. To tell you a little bit about me, so I did a PhD way back in the 90s in Adelaide in machine learning. So yeah, AI and machine learning's been around that long and even longer, but it's only become really popular in the mainstream in the last couple of years. This is some of the wacky stuff that we were doing back then. I was working a lot in computer vision. This is a postdoc position I had in London, and we were looking at, analyzing video, doing face detection, recognizing people's gestures, and using that to control pan tilt zoom camera. So we had like an early version of Zoom where you could crop out someone's face and send it, which was a big deal at the time, and even just recording video to a hard disk back then was unusual and a bit challenging. And I guess, I love academia and research and writing papers and all that, but I was getting the feeling that, we just look at an idea and then write a paper about it, move on to something else. And I really wanted to see these ideas right through to an application. I could see that there was a lot of potential for machine learning and AI to make a big difference in solving real world problems. So I soon went into industry and was looking at, how can we use this to really do stuff? And worked for startups and hedge fund and for defense. And this was at this first startup that I worked in the 2000s. We wrote software for full video surveillance and video analytics solution. So we're doing things like face detection and recognition, tracking people from surveillance cameras. And one product that was really popular was this people counting. So if you have a big doorway, a big area with a camera looking down, then you can track people and count them going in and out. And you get statistics like this of how foot traffic is going over the day. So we had that installed in places like Melbourne Exhibition Centre and Luna Park, which is a theme park in Australia. And this kind of technology is now being used a lot in retail. You can set up cameras, outside your shop and inside your shop and work out how many people are walking past, how many people are coming in, where they're going in the shop. And then you can use that to do analysis of the kind of displays you're putting in your shop. If you put a new display out, is that bringing more people in or less people in? Um, where you put things in your shop and how that affects shopper behavior. So that all that business intelligence kind of stuff. Another startup that I worked for was called Footsie in Canada, and sorry, just got to move this thing. How do I move it? Move it out of the way.
Hey, so welcome to Footsie.
So what we were doing was trying to measure your shoe size for online shoe shopping, because a lot of people don't have confidence buying shoes online because they worried that the shoes won't fit and they'll have to send them back, and that's a pain. So the idea was that you could use your phone to scan your foot in 3D and get a 3D model of your foot and use that to recommend a shoe size for a specific shoe, or even recommended shoes that are better fit for you. And this was really interesting work. I mean, you might think I'm a size 10 or a size 6 or whatever shoe, but that's just one number, and your foot is a three-dimensional object that's fitting in another three-dimensional object. So there's actually quite a lot to it when you start looking into the problem. So we had lots of different machine learning, computer vision components in this. And what we're seeing here is the app that we had for scanning your feet. So we needed to get good pictures of all sides of your feet to do a 3D reconstruction. But that's kind of like specialized knowledge, for someone like me to know what makes good pictures, where the foot's framed in it, what the angles are, what the lighting is, that there's nothing, occluded and things like that. So we were looking at how can we embody that knowledge into the app. And so this is an example of the app running where we had, this is a while ago now, but we had 3 different neural networks running in real time on an iPhone. One of them's just saying, are your feet there or not? So stop working when we're not looking at feet. And the next one is identifying where the feet are. You can see how it's drawing that mask around that in real time. And then the third one is looking at the angle. So if you think of looking down like a clock face, we want pictures from all the different angles. And that neural network was just saying, we're at this angle where it's just looking at the image. It's not using the IMU sensor on the phone of where it's looking. So with this, it goes around and you scan all the, get all the pictures. They get uploaded to the cloud. And then the backend processing did a 3D reconstruction and then fitting a 3D morphable model to that. And then you get a model like this of your feet, and then that has, statistics on your feet compared to other people and things like that. So we also had this 3D model where we looked at populations of feet and what makes different people's feet different and things like that. So, you get an indication there of some of the different kind of uses of machine learning and AI and what you can do with different kinds of data and the different components and how they fit together. I've also been involved with the Australian Institute for Machine Learning. So this is a part of the University of Adelaide, and it's come out of a group that's ranked very highly for research papers. So they they get a lot of papers published in top class venues like CBPR, if you're familiar with that. And it's by far the biggest research group in Australia. And I'm a visiting researcher there still, but I was until recently, the um, technical director for defense. So I was running a lot of industry projects and projects with defense, and also projects to do with art. So this shows you some of the things that they do at the Institute for Machine Learning. It was co-located with the Australian Centre for Robotic Vision and the Centre for Augmented Reasoning as well. And in about 5 years ago, I started my company. I guess the thing that drives me and the reason my company exists is to get real value out of AI for businesses and for solving real world problems. Because I've worked on a lot of things where it was kind of a technology push, um, in a group where they say, we've got this algorithm or this technology or this idea, and we're going to build it, and then we're going to go and find a customer. And then often you find that there's no customer. And so, I wanted to make sure that the technology has been used to really provide value with that good product market fit. So I guess one thing that makes here's my team. So we've got 4 machine learning engineers and my bookkeeper as well. And here's an example of some of our customers, growing list of companies we've worked with. Just wanted to say, what's different about us is that I think is that mix of the deep research knowledge with commercial software development expertise as well. So you get there's a lot of companies out there that can produce software and use APIs to use machine learning and AI, but they don't really understand the algorithms going on underneath. And then you get a lot of people from universities that have in-depth knowledge, but they're not great at deploying real-world software and commercializing software. So we have experience with both, so that makes us different. Here's examples of some of the more examples of things we've worked on or things we're working on in the company. So when I was doing art stuff at the Institute for Machine Learning, we were in the top left there, we're working with Laurie Anderson, and she's an artist in New York who's had a big, long career. Some of you might be familiar with her. She's very interested in literature and writing. And so we, about 4 or 5 years ago, we started working with her to make tools with large language models that could produce prose and lyrics that sounded like something she would have written. So we're like cloning her literary voice. And we use this to make like a translation of the full Bible that sounds like something she would have written. And that's now on display in the Smithsonian. And there's only 2 printed copies. One's at the Smithsonian, one's in Adelaide. And we went on to clone her audio voice and, her face as well, and had this deep fake clone of her that
when
she
it gets
used in
dark,
some presentation.
we go home.
So that's, fully synthetic in that what she's saying
Just a perfect day.
was generated by a
And
computer.
sangria
The sounds
in the
generated
park.
by a computer.
And then later, when
is.
it gets dark,
So this is
we
a few
go
years old
home.
now, and the technology's moved on a bit, and this looks a bit uncanny valley compared to that. But since it was for art, it's kind of good as well. She liked the fact that it looked a bit unreal, and that it's like she had this doppelganger out there that was copying her. Up in the top right here, the company I've worked with in Silicon Valley called Loose Cannon, they make this Milo the action communicator. I'll talk a bit about that later. which is a communication device, and we did some audio processing for that. We've done quite a lot of overhead imagery work, and here's like a satellite image and shows all the things you can detect automatically in that. In the middle here, we've used AI to make beer. So I'm also co-founder of a startup called Deep Liquid, and we made Australia's first AI-generated beer, where we used machine learning to make the recipe for the beer, and then the brewer brewed the beer. But that's moved on more to doing things like this. We've got this AI bar that's got like 4 or 6 kegs of different beers in it, but one tap, and then you use an app to answer some questions, and it makes you a customized beer just for you that you like. But the bigger idea is to get customer feedback about beverages and products, and get that back, quickly to the producer to help them to make better products and make recommendations to make better products. So it's about tightening that gap between the producer and the customer. And FTSE we already talked about. So as I said, you're probably getting the sense now, hey, Jamie hasn't talked much about ChatGPT, but he's talking about all this other stuff. So it just goes to show that machine learning and artificial intelligence is not just generative AI. So this is a good diagram from someone else that gives a good idea of the context that, artificial intelligence has been around for a while as a concept of, thinking computers, or computers that are smart, I guess. And it's also been a research field in computer science mostly. And then within that, there's this idea of machine learning, which is more related to statistics, where you have data and you're learning from data. So you're learning by example to perform a task from lots of data. Within machine learning, then since 2012 has cropped up this field of deep learning that you might have heard of. So all your ChatGPT and Midjourney and all that, that's all kind of deep learning. And then generative AI within that is about having a system that can generate text, generate sound, generate images. So usually the kind of data that you're feeding into the system is now coming out of the system. So this gives you an example. Like a typical machine learning system would be, you put in an image, say here on the left, and then you just get like a number or a category on the right. That would be a typical system. So generative AI is kind of going the other way, where you would put in, hey, give me a strawberry, and then you get an image. So that's what makes that different. This just gives you a quick idea. I didn't want to get too technical, but a quick idea of how machine learning works. And I just want to point out there's kind of 2 phases. So the first phase is offline. So you're just doing that, beforehand, that you've got lots and lots of examples of the task you want the system to perform. So here, say the task is, we've got images and we want to just categorize them and say what's in the image, a strawberry, a person, a bicycle. So you've got lots of pairs of these images and the label, lots and lots of them. And then you train a model, like a neural network, to be able to produce the same kind of outputs given the inputs. All right. So that's something you do offline. It's called model training. Then when you go to use that trained model, you take the outcome of that training process, and that now you don't have the outputs, you just have the input. You have an image, like a picture of a bicycle, and you feed it into the model, and then you want it to say, what's in that image, and it predicts that it's a bicycle, for example. So you got those 2 different processes. So when you're using ChatGPT, you're just using this already trained model. And once the training has happened, in most cases, the model is not getting updated. It's not getting trained anymore. Okay, it's just kind of frozen now. So when you use ChatGPT, using this frozen model, but you're giving it your text on the left, and then you're getting your output text on the right. We're going to have question time at the end, by the way. So if you've got any questions about this stuff, just think about it. So you're probably thinking, oh, stop telling me all this stuff about neural networks. I want to know how this is useful for my business. So get on to some practical things. So talk about overhead imagery. So I've done a fair bit with overhead imagery, did a lot when I worked for defense, in particular. This shows one thing you can do with it. You can have an image input and feed that to a neural network where it will label every pixel in the image as one category. So you can see here where it's labeled buildings in dark blue and trees in green, car parks and roads in white and cars in yellow. And you could do this to estimate how much vegetation there is or area of things. So that's called semantic labeling or segmentation. And this is a challenge that some years ago in 2018 I was coming first in a research challenge on that. I was also had a team where we came second in a US DoD challenge of detecting objects in satellite imagery. So here there were 60 types of objects. So here you can see like buildings are the red boxes, and oil containers are yellow, and we've got cars, trucks, rail cars, ships. So you can see you could kind of scan the whole world and find all these different things. And you might think, well, what use is this? Well, actually, I came across a company in the US that Orbital Insight, and their customers are often banks and things like that. They detect things in overhead images and then provide that as a subscription service to finance companies. So, for example, they could look at how many cars there are parked outside a factory car park and look at the statistics of that over time and try and work out when companies are about to release a new product or something like that. And then, that might be a predictor for the stock price or something. So it gets you thinking about, you'd think, what the hell would satellite images have to do with finance? And then, it's like getting intelligence, I guess, about that. Also estimating how much oil there is in a whole country and things like that. I ran a big defense project at the Institute for Machine Learning where we were looking sort of pre-ChatGPT, we were looking at how to do question answering on lots of geospatial data. This one on the left gives an example where you've got lots of different kinds of data, and then it's translating your question into an SQL query that gets run on that. So if you've been looking at this AI stuff recently, you've probably seen examples of that more recently happening with ChatGPT and so on. So the cool thing about that is you can combine lots of different data and get lots of different kinds of results as well as you would from SQL queries. So SQL is the language you use to write queries for databases, basically. On the right, it's more with unstructured data. So say you've got a database of millions of tiles of these, overhead, aerial or satellite images, and then you could just ask a question in text. So here, or a search term in text, he was saying a residential area near a beach. And although it's never been trained on that combination, it's able to find, different examples of that, which is what you'd expect, from, say, ChatGPT, or something like that. But, something like ChatGPT might not do so well at this task because it might not have seen many satellite images before. It's seen lots of social media type images like cats and dogs, but might not do so well as this. So this could be useful, say in real estate where you're saying, I'm looking for suburbs that have these qualities or something, to look for specific houses maybe that a customer's asked for with certain requirements. More recently, we worked with a company in Canada called Audette, and they are working on making carbon reduction plans for office buildings at scale. So, you can have a building engineer go to an office building and look at all the equipment in the building and characteristics of the building and say, here's what you should do in the next 30 years to reduce the carbon output of this building. And, you got to take out this air conditioning system and put in this cooling tower and replace your windows with double glazing and all this stuff. And the more they know about a building, the more detailed they can make that plan. But, you know, even with a bit of information, they can come up with some kind of plan. So what they're looking at is getting richer and richer information about all the buildings in the areas they're interested in. So the idea is that they could say, here's carbon reduction plan for a whole city. And so we help them with detecting the equipment, like the HVAC equipment on top of office buildings. So it gives you an example on the right here. You know, sort of process we went through is we got data. We had the experts work out what are the things we want to detect, give lots of examples of drawing boxes around those, and then trained a detector to be able to do that. So you can see you can find things like solar panels and different kinds of air conditioning units and gas pipes. And then this enriches their database about the buildings, which we estimate would be improving it by about 10% in terms of the information content. Another example of some different kind of imagery is with a company in Adelaide called Woven Optics. So sheep have been very important in Australia in terms of exporting wool and having high quality wool. And typically what a farmer does to find out, you know, what are the sheep with good quality wool or different levels of quality is that they go and they cut a sample off the sheep, and then they send it off to a lab, which takes about 2 weeks and costs a bit of money. And they get back an estimate of the average fiber thickness on the sheep. And what Woven Optics are doing is that they're experts in microscopy. They wanted to have a handheld device that they could just walk up to a sheep and like stick a comb in its wool, and then get an instant estimate of the quality of that wool, which would be, you know, as you can imagine, be quite disruptive. And you could take measurements on different parts of the animals and things like that. So these are the kind of images that the device gets. You can see for the wool. So we developed a neural network-based algorithm that would take these images as input and then just output the predicted wool quality or the wool average fiber thickness from examples that we were given for training. You know, a more traditional approach to this would have been to use image analysis techniques to try and segment the fibers and then, you know, delineate the fibers and then measure the thickness on each fiber and then average them. But those kind of methods quite prone to error. You know, I've worked a lot on that in the past, but they're quite error prone. You can see, for example, we've got fibers in different levels of focus, so you would have to ignore some and things like that. So the great thing about deep learning is that it kind of discovers those features for itself, and it's also leveraging vast amounts of data that it's been pre-trained on to get better results. So that formed a basis for their prototype for the wool quality assessment. So Milo, I don't know if anybody here's ever heard of Milo or used it or seen it, but this came from loose cannon. And if you've ever watched Star Trek and seen how they got the communicator and they like talk to each other, it's pretty much like that, but for extreme sports. So everybody in a group wears this and it sets up a mesh network, radio network to communicate to each other. So it doesn't rely on cell phones or cell networks. So you could be out skiing in backcountry and there's no phone reception, but you can still talk to each other. And so it's a pretty cool idea. It's also waterproof and everything. And as you can imagine, there's quite a lot of wind noise, you know, people, you know, windsurfing or riding a bike or skiing. It's going to be a lot of wind noise. So we help them to do noise reduction. So removing noise, the wind noise, to just leave the voice, and also voice activity detection, because these are battery operated devices. And if you have all the algorithms running all the time, you just wear down the battery. So you only want to process when the voice is active. And whatever we do on here, it's got to work on a battery powered device. So if any of you have a GPU on your computer, you know how much power they suck up, and usually GPUs are used to do this kind of machine learning processing. So with low power devices, you have to specialize the solution so that it works on a low power device. So we developed, algorithms, for example, for voice activity detection for them that could work at lower power, and also analyzing and testing a whole bunch of different algorithms, as you can see here. I won't go into the details, but just showing that the method we came up with was working better than alternatives. And it's quite a lot of work to get the test data set right, and to get to do all this analysis. Here's an example of kind of results. So this is a waveform of some audio, and the yellow blocks are showing where it's saying somebody's talking, and you can see a spectrogram down here. I actually have a video of this, because I wouldn't embed into oh, it is working.
My dear child, Henderson was taken at 10. Before you go, I want to hug you. She's
So this one here, like, you might not have been able to hear that. It's a really quiet voice, and it still picked it up, which is quite amazing. And that, and
How
the noise
long?
also is quite good.
Oh, how long does the battery last on that?
I'm not sure. They keep bringing out new versions. So yeah, I'm not up with the latest specs of where that's at. And it was a few years ago that we did this work with them. But as I understand it, they're on sale in places like REI and that now. So it is becoming widespread. So it was really interesting to see that go from nothing to a product that's in a shop, and the things you have to do, all the practical things, like how do you just get a speaker to play clearly in a plastic cavity where it's not rattling and it's loud enough, and so they have specialized engineers that know all that stuff, and how to get good results. And then there's all the voice interface and everything as well. More recently, we've been getting into renewable energy and electric vehicles and solar and things like that. It uses a lot of IoT data, that is Internet of Things data, which again is quite different from text and images. So one company we've been working with is Lavo Digital, and they're a Sydney company innovating in the solar asset management space. So in Australia, there's all these mid-sized solar farms popped up that generate energy during the day and then sell that into the electric grid. And so investors see this as an investment, let's pay to set this thing up, and then over a period of 10 years, it's going to return on the investment by generating energy and that we can sell. So you have these asset managers that work to manage the solar farms, and they just want to maximize the profit or maximize the return on investment of those solar farms. So they need, as you can imagine, they need a lot of information, and they need the control of the solar farm to be automatic and be doing the best thing, doing the optimal thing. And so it gets a little complicated in Australia. You have the prices of the energy market. You also have these long-term generation certificates, which is like an incentive that you get from the government for generating renewable energy. And then you also have prior purchase agreements and something called FCAS, which is about stabilizing the frequency of the grid. And it's something interesting in Australia that I don't think you get in other countries maybe, is that the price can go negative, and often goes negative in the day, which means if you're generating electricity, you pay a penalty to generate that and put that in the grid. So at that time, you want to turn the solar farm off, right? So that's why then batteries become important, because to capture that energy, you want to put it in the battery and then sell it later when it's expensive. So we're using machine learning to make all those decisions automatically and use predictions of weather and predictions of prices and things like that to work out what's the best decision and control at each point. Some other clients have started working with recently. 7Gen is a company in Canada that leases electric trucks. So they have fleets of trucks and fleets of chargers for the trucks. And they just want their customers to have a smooth experience, they use the equipment and it all works reliably. And, reliability is really important for their customers because they have, a lot of people doing deliveries or providing transport. And so they want to maximize uptime of their system. So we're helping them using machine learning on their data, telemetry data that comes from trucks and chargers to predict faults before they happen. So they could deal with them before the customer, wakes up and finds their truck didn't charge for overnight, for example, And Green Frog Systems is a solar lighting company here in Adelaide. So they make autonomous lighting for roads and intersections and paths and things that don't need to be connected to mains power, and they're using solar. And when they are quoting a job, there's a lot of different possible combinations of equipment. And we're helping them to use data to produce more accurate quotes and predict what's the energy consumption and everything of the different configurations of equipment. And they have quite a lot of data. Both these companies, have quite a lot of data. That's, one thing that drives, customers to like this to work with us is they're sitting on this data and they're thinking, oh, there must be we've got an inkling that we can use this data, that we're not getting the full value out of it. And it's something that sets us apart from our competitors. So that's, one thing to do with machine learning and AI that kind of drives people to use it. And yeah, I could go on about language models and things like that. So more recently, we've started working with language models, and we made like a private version of ChatGPT that, is not as fully featured as ChatGPT is now. It's more like where it was a year ago or something. But the cool thing is that it's all on your private cloud account. So we started out working with open source models. And so I just finished what I'm saying and then answer your question. We just started working with open source models and, running them on GPUs, and it's quite expensive to host. So then we switched to using the Azure OpenAI service, which is like ChatGPT, but on Azure, on Microsoft Azure, not on OpenAI. And so they're not really interested in training the model. They're just deploying OpenAI's models on Azure hardware. And so the way it's implemented kind of looks like this, that our stuff is on our Azure account. So we've got a web app and an API and all the conversation history. It's stored on your own account. But then when you're actually sending things to the language model, it goes to the Azure service. And in terms of storage, they do store your data for a couple of weeks because they want to do quality control on it. Just make sure that, you're not violating their terms of service, like saying, make me a bomb, or how would I make a bomb or something like that. So looking for dodgy stuff. So in terms of privacy, that would be the only risk there, that potentially a Microsoft employee could look at it. But I mean, that's the same with all cloud stuff, right? That you've got to trust the cloud provider. And sorry, yeah, was there a question there?
Yeah, Charles had a question.
Yeah, I apologize if this question is not directly related to the current slide, but I'm wondering how many years do you think it'll be before AI completely replaces human bookkeepers? Not accountants, but just bookkeepers.
Yeah. I'm just thinking about what bookkeepers do. Yeah. I don't know, because like with my bookkeeper, there's lots of subjective ad hoc things. So, there'd be an automated part of it that, you could do now to draft things, I think, things like reading invoices, reading receipts. I think there's already solutions for that. But then all that ad hoc stuff where you've got to explain things and then that would be, you would have to have a chatbot kind of solution for that, I guess. And that's where it would be translating, be kind of like the data analysis side of ChatGPT, I guess, where you're having a conversation that says, I'm doing this in Xero or whatever program. Do you use Xero in America?
It's mostly QuickBooks, but
QuickBooks?
about 10% market share for Xero, maybe. I'm not sure.
Okay. Yeah. So, you'd be having conversation, then it would say, I'm doing this in QuickBooks or whatever. But that's kind of getting into that agent, like language model agent area where if it's taking actions, because at the moment you use ChatGPT and then you kind of review the outputs and go, edit this, I'll edit that, or I'll ask for it to change this and that. And having something autonomously taking actions where you're not aware of all the actions it's taking, that's kind of another level of trust that we're not at yet, I think. But it could say, here's what here's my draft of your accounts this month. Here's some recommended actions, and then you go and approve everything. I think, it's possible to start doing that kind of thing now. And, I talked to my accountant and I'm going to start working on an application with him about forecasting budgets that more accurately that he's interested in.
So I guess my question is pretty specific. We currently are using AI and prompting to review the quality of a bookkeeper's work and provide suggestions that a bookkeeper might not think of about how to reduce expenses or but I guess what I'm wondering is how many years do you think it'll be before, instead of doing what we're doing now, which is sort of combining AI with a human bookkeeper, that there will no longer be a need for a human bookkeeper? How many years away do you think that is?
Yeah. Like I said, it comes down to that, is it taking actions or not? And, I think over time we'll give more and more trust to AI systems, but it's going to take time to give trust. I mean, look at driverless cars, for example. Like, I think they're quite good, but we still don't trust them enough. At what point are you willing to put your bank account details in ChatGPT and say, go crazy with my credit card,
Well, let me ask it this way. Is your intuition say that we're more than 10 years away from people trusting their bank account and everything with the AI and not having a human bookkeeper? Would you say we're more than 5 years away? Like what would you say is the rough time frame that you think it's going to be?
Well, predictions are notoriously inaccurate, especially ones about the future. So it's hard to say. Yeah, I don't know. I don't really want to make a prediction of that. I would have thought, more like 10 years or something.
Got it. So we're definitely not there now, and you don't think it's like right around the corner. Okay.
Yeah. I mean,
Thank you for
you look at driverless cars. I mean, that's pretty that's safety critical. So that's a different kind of thing. But that's been around. They've been around for quite a while, and still not widespread adoption of having
We
them
got him here, right, Nicole?
Yeah, you do. And I saw my
Up
first
here.
one in Seattle last week.
Yeah, they're rolling them out.
Yeah.
Yeah. And
So
riding in one is scary. I think it's scary.
so what's that take, like 15 years or 20 years, I think, maybe?
But I would use AI in any accounting software because I am not an accountant and I don't know what I'm doing. So I also probably wouldn't be the best one to use it, but I'd use it tomorrow if it were available.
Yeah. I think, it depends, because I guess your question was, like fully fledged, but what about just parts of it? There'd be certain tasks that today you would say, sure, automate that.
Yeah, I think it's a gradual process. So right now, what we're building, you still have a human bookkeeper in the loop and an accounting supervisor, and we're trying to make everything more efficient and more reliable and add value with the AI. But the current model is it's really a technology-enabled service rather than a AI only solution. And I'm just wondering how long we're going to be in that stage, and it sounds like it could be a decade.
Yeah, I mean, decades fly by because
Yeah,
it's been
they do. They
2 years or a year and a half since ChatGPT came out, and it seems like just yesterday. But
I got an 8-year-old. It seems like he was born yesterday. Well,
yeah.
thank you for taking the time to go down that rabbit trail. I appreciate it. I hope
Oh, that's all right. That sounds really
it
interesting.
was interesting for everybody else too.
What you're doing, yeah. Yeah. So anyway, that's just to talk about, different setups, because a lot of companies, like, they don't have the liberty of sending their data to OpenAI, like health authorities, defense, things like that. So one use case of that would be, you got, say, a defense contractor and they're writing code and they don't keep their code on GitHub. They've got to have it on premises, can't leave their network. But then they're not able to use like GitHub Copilot to get code suggestions. And it's also like a security risk because you get developers saying, well, I'm going to use it anyway. And they kind of, sanitize the code and send it off, and that gets risky. So the idea would be to have this all on premises and be able to give code suggestions would be one good example.
Dan has another question. I also want to just quickly point out, it doesn't have to be ChatGPT in here. It can be other LLMs because I know there's issue with contracts in other countries and they don't want their data on US servers. And so there's LLMs like Falcon that's based in the Middle East. And some people prefer to use something like that because the US government is known for spying or getting people's information, and so even with this and you being in Australia, I know there's some issues with Australian government contracts and them not wanting to use ChatGPT because their data would be hosted in the US. So Azure allows you to use any LLM to plug into this same scenario.
Yeah. Yeah, I guess when I say ChatGPT, I'm kind of using a concept because there's Claude and all that as well. And people are saying Claude's better than GPT 3.5 at the moment.
Yeah, it is better than 4. Dan, sorry, Dan, do you have a question?
Yeah, I'm just curious, where you've got sensitive information, say it's personally identifying information or something like that, and you've got a system that isn't maybe fully secure that you want to utilize. Has tokenization, on either side of the equation kind of entered into the conversation? So for instance, if I had a large batch of data that contained a lot of personally identifiable information, could I sort of sanitize it on one end and tokenize it and then get the results back and correlate it in that fashion?
Yeah, so like sanitizing and desanitizing data, I think that's what you're asking.
Yeah.
I can't remember what it is, but I have seen one system where that was like a solution, a packaged solution that they had. it's the selling point for their product was that it does that process for you. The
So there's somebody
will
with a
be,
secure platform that acts as an intermediary, essentially, like a vault, a data vault.
yeah, not sure of the details, but it was meant to be secure. The issue is the sanitization would be down to the quality of the result of the language model. So, it's probably using the language model to say, replace all the names here with made up names or something. And then if it misses one and puts in a real name, then, because we know that these language models will still make mistakes. There could be errors, I guess. But, no system's going to be perfect or perfectly secure anyway. So, but yeah, I've seen at least one solution to that as a package solution, apart from you getting in and coming up with your own prompting and stuff like that. But there would have to be some storage, right? Because if you've got 50 names in there and you've replaced them all with, it says name 1, name 2, name 3 or something, some kind of label, then when you desensitize it, you're going to have to go and replace with that association. So you have to keep record of that association.
Yeah, and that's actually the idea of tokenization. So when we do merchant processing, for instance, we need to associate an account with sensitive information to a transaction. And so they create a random token ID for it that can associate on both sides of the transaction.
It's interesting. Yep. A question we get a lot is about using data with language models. So this is something you're probably all familiar with anyway, but just showing that we've done a bit of work using our private chat system with documents that are in SharePoint and being able to, summarize documents in a folder and things like that. We've done a bunch of other things with LLMs, but they're kind of internal demos where we were working with the client, we were coming up with concepts and making demos, and some of the examples were asking legal questions about emails. If you've got some court case happening and there's a history of emails, could you ask questions about that? And we use the Enron data set to come up with some examples.
There were also some
that.
questions.
This is like a back-end demo. It just shows that, if you had a question like what allegations are made against Jeffrey Skilling, it'll give you a summary answer and then show you what documents we used. So this is you might have come across that term RAG, or retrieval augmented generation. It's using those kind of ideas. Another one would be, regulation is a big issue in Australia, probably is in America as well, where, for example, you might think, does my product meet food health safety regulations? And you can have a database of documents about food health safety and then ask a question and have it kind of read those documents and come up with the example. So here we've asked, what are the regulations around baby food safety? And it's gone and retrieved relevant documents and then used them to answer the question. But the interesting thing here is it's kind of like a two-stage process where first we retrieve the documents and then we do more intensive processing on the documents using the language model, like you would upload a document to something like ChatGPT and ask questions about it. Because the kind of vanilla flavored RAG solution is that you get relevant sections from different documents and you just paste them into the prompt. So you're not looking at the whole document. So this is different in that it's like a two-stage processing of the documents. But I think we'll see a lot more of that, applying to data happening. Yeah, I've got more examples. But I think we'll end the talk there. Yeah, so hopefully that's got you thinking about different applications of AI and machine learning. when making you aware of when you would need a custom solution as opposed to an off-the-shelf tool, and maybe get you thinking about in your own business, do you have some data or a problem where you think AI or machine learning could be used where you didn't realize it before? Any questions?
Thank you, Jamie. Any questions, any custom solutions that you're considering that you'd like to run by Jamie since he's here? And one of the things that we get asked about a lot is that private occurrence of ChatGPT or something with the AI that they can talk to. And one of the things that you can do with the Azure is you can have all your information in there. In theory, you could use Copilot for that, but it doesn't really work for your whole database yet. And so in Azure, you could put a lot of information and have it accessed by an LLM to be able to search through all of your files in a private environment. And I think that's a really valuable use, and it gets people a bit more comfortable with using AI with their data.
Yeah. Yeah, and there's lots of different ways of doing it right now, I guess. So you've got, the Azure are providing a bunch of tools that you could have programmers go in and use that as kind of cloud API tools. And then you have off-the-shelf tools like that. There's another one called Chatbase. There's an app that I know at least does individual documents. I'm not sure if it will do a whole batch of documents. But again, like there's somebody that you don't know them and you're giving them all your data. So it's not a great situation. But then people are doing it all the time, right? Like, yeah. I was talking to someone, they're saying, we have to give an audit to the government to say how we're using our where we're storing our clients' data. And then the next thing they're telling me they use Grammarly. So that means all their documents that, that's getting sent. So who knows where to do grammar checking on them, all the documents. And you use these things, but not think about it. And, like personally, I put so much trust in Gmail and Google, and, I've put so many startup ideas and technical ideas into emails where technically Google would be a competitor, and that they could like look at that idea and have one of their million employees go implement it.
Yeah. I mean, this kind of goes to our topic next week. We're talking about AI use policy, and we've got a lawyer coming on, and how are not any policies that include, like in cybersecurity policies, there's no insurance policy that covers AI yet. And like his recommendation is having an internal use policy, and we look at the EU standards, and if it's up to the EU standards, it will probably hold if any incident were to happen, within a company, because it would probably get treated like cybersecurity, which again, like EU standards are kind of best practice, because usually they're the most stringent, like GDPR and all of those things that we try to follow. Do you have any thoughts on that?
Yeah, well, there's a few different legal things going on as well about the copyright of data, and is an AI agent a kind of an entity for things like patenting? Like can AI create a patent? I think the recent ruling was no, things like that. Yeah, well, for my company, liability insurance and that, they recently said that, they'd only cover to a certain amount because they saw AI as being risky. So, yeah, I guess it is going to come up as an issue. And yeah, things happening in the EU in terms of standards. Yeah, I don't have any more specific comments or information on that, I guess. But
Well, thank you. Thanks for taking the time and walking us through this. I'm sure everybody has some ideas rolling around, and if they want help implementing, that's what you do, right?
yep.
And
Yeah, but even if you just want to, bounce an idea off me or something, then go for it.
thank you. And email is the best way to get a hold of you?
Yeah, email or LinkedIn. I've put the QR code there, so
Okay.
you can message me on there.
Thank you. I know that there are people on here who are definitely working on that want their own custom solutions. Some people are building them, and some people are determining what they're going to build still. And there's this gap of knowledge when you go from out of the box to custom solution. And then that's where we need someone like you to help build and also guide that process and think it all through. So thank you. Thanks for sharing everything that you have been working on. And I look forward to catching up and hearing about more projects in the future.
No problem. Thanks for having me, and I hope it was helpful.
Yeah, thank you very much.